Okay, in this first college algebra video, we're going to talk about this section here, which is, I labeled it section 1.1, solving linear equations and inequalities, and this will likely be broken up into multiple videos. Okay, before we talk about solving linear equations, let's take a look here at the properties. The first property I want to talk to you about is if you have an equation a equal b, then you can add the same number to both sides. Now actually you can write this as one property if you say that c can be positive or negative, but I went ahead and wrote it as the positive property and the negative property down here. So basically you can add the same number to both sides of an equation and still have an equation, or you can subtract the same number from both sides and still have an equation. So over here I have an example. Let's say you have x minus 5 here equals negative 3. Then to isolate the x, which is our goal, you'll want to add 5 to both sides. So if we were to add 5 to both sides, then what would happen is this minus 5 and plus 5 would cancel, and then we add 5 to this side, minus 3 plus 5 would equal 2. So all I would have on the left is x and on the right is 2. So this is a pretty simple equation. The next one down here shows that I have x plus 3 equals negative 2. And so to get the x by itself, I can actually subtract 3 from both sides. So if you look over here, I took the x plus 3 and just subtracted 3. And on the other side, I took the minus 2 and subtracted 3. And then, of course, the 3's will cancel and just leave x on the left. And then minus 2 minus 3 is negative 5. Now, you can also do this same type of operation, but you can do it with multiplication. Like, for some reason, if you've got your variable x, and, of course, your variable can be any letter, but I use x in most of these. Let's say over here you have the variable x divided by a number. So you can see here I've got x divided by 3. So basically to cancel out the 3 in the denominator, I need to multiply this whole expression by 3. And this tells me that if a equals b, then a times c equals b times c. And that's true except for 0. If c is 0, then you can't just multiply both sides by 0 to get rid of the equations. Okay, so here I just took the x over 3. Notice right here I just took the x over 3 and multiplied it here by, right here, I multiplied it by 3, and then here I multiplied 7 by 3 on the other side. Now what happens is, of course, 3 over 3 is 1. Some people like to say that cancels, but there's really two kinds of canceling. There's the canceling where you add and subtract opposites, but that cancels to 0. Now there's also the cancel where you multiply a number by its reciprocal, and that's what we're doing here. But when that cancels, you get 1. So really what we have here is the number 1 times x. And of course 1 times x is x, and 7 times 3 is 21, so that solves that equation, giving me 21. And of course if you can multiply both sides of an equation by the same number, then obviously you can divide both sides of an equation by the same number. Again, as long as it's not 0. So if a equals b, then a divided by c is equal to b divided by c. So let's take a look down here. Let's get rid of that. Let's take a look down here at this equation, and you'll see I have negative 5x equals negative 30. So what I want to do to isolate the x is I need to take this x, this negative 5x, and I need to divide that by negative 5. And of course if I divide that by negative 5, I have to divide the negative 30 by negative 5. So here you'll see I'm dividing negative 5x by negative 5, and on the other side I'm dividing negative 30 by negative 5. And of course what happens again, negative 5 cancels with negative 5, and it gives me 1, so that's like a 1x, which is just x. And then on the other side, remember, a negative divided by a negative is a positive. So if you need to review your signs, go back and review them. So x equals 6 is the answer to this equation. So now let's apply some of these properties to some basic equations now. So here I have 3x plus 7 equals 22. Now I'm going to start out using the properties the way I explained them, and then I'll show you something called transposition or transposing in a minute. So here I want to get this 3x plus 7. I want that to be by itself. I want the 3x to be by itself. Okay, because once I isolate the 3x, then I could just divide both sides by 3. But the first thing I want to do is get rid of this 7. So I'm going to bring the 3x plus 7 down, and then I'm just going to subtract 7 from it. Now remember, I can do that as long as I subtract 7 from the right-hand side. So when I subtract 7 from 7, of course, they cancel each other out. So they're just going to cancel and give me 0. And of course, 3x plus 0 is just 3x. And then on the right-hand side, 22 minus 7 is 15. So over here, I just have 15. And then I have 3x equal 15. Now, this is kind of like a problem I showed you a minute ago. You have a number multiplied by x, and so to counteract that, we're going to actually divide this number by the coefficient, which is 3. So we're going to divide 3x by 3, and that's, you see that here, 3x divided by 3. And I can do that as long as I divide the other side by 3 as well. So now 3x over 3, remember 3 over 3 is 1, so that's just 1x, which is x. And then 15 divided by 3 is 5. Now let's take a look at one that has a fraction in it. Okay, on this one, you actually could multiply everything by -3 first, but I'm going to go ahead and isolate this expression right here first. So let's isolate the fraction first. So what I want to do is bring down this expression, and since I have a -5, to isolate it, I'm going to add 5. So notice that I brought down the expression, and then I added 5 right here to it. And remember, I can do that as long as I do it to the other side. So I add 5 to the other side. Now, these 5's cancel, so I'm just going to have x over -3. And over here, -3 plus 5 is 2. So I have x over -3 equals 2. Now, I want to figure out a way to get rid of this -3. Well, I just showed you that when you have a variable divided by some number and you want to eliminate that number, just multiply by that number. So if I'm dividing by -3 here and I want to eliminate the -3, I just want to multiply this expression by -3. And then, of course, remember, -3 over -3 is just 1, and 1 times x is simply x. And then, of course, since I multiplied this side by -3, I got to multiply the other side by -3, and -3 times 2 is -6. So that's how we solve some basic linear equations. Let me show you a couple more. On this one, I'm going to have to distribute. So here I have 3 times 2x minus 1 plus 5 equals 5x plus 2 times 3 minus x. Now what I'm going to have to do here is I'm going to have to use the distributive property, which you may need to review. But 3 times 2x minus 1 would be 3 times 2x, which is 6x. And then you also have to multiply 3 times minus 1, which is -3. And then I just bring down the 5. Over here, I'm going to just bring down the 5x. And then I have to distribute this 2 through this parentheses. 2 times 3 is 6. And then 2 times minus x is minus 2x. Okay? So that eliminates my parentheses. And, you generally want to do that first when solving an equation. Now, I also want to collect any like terms here before I move forward. So notice that -3 plus 5 can be combined together to give 2. And then just bring down my 6x, and I have 6x plus 2. Over here, I have 5 minus 2x, which is 3x. And then, of course, bring down my 6, and I get 3x plus 6. Now, right here you'll notice that I want to get rid of the 2. I want to get all of my x's on the left. So what I'm going to do first, I'm going to get rid of my 2. Now you can do 2 steps at once, but I'm going to do this one step at a time. I want to get rid of my 2. So I'm going to take 6x plus 2 and subtract 2 from it, and then that will cancel those 2's. And then over here I have 3x plus 6, and I subtract 2, and that just gives me a 4, for 6 minus 2 is 4. So on the left side I have 6x, on the right side I have 3x, and then plus 4. Now, to finish this, now that I got my numbers on the right, I want to get my variables on the left. So let's subtract 3x from both sides. And when I subtract 3x from both sides, I'm going to get 6x minus 3x here, which gives me 3x. And over here I'm going to get 3x minus 3x, which of course is 0. And 0 plus 4 is 4. So I have 3x equals 4. And now just divide both sides by 3. Of course you get, if you divide this by 3, you get x. And if you divide this by 3, you get 4. You can kind of do some steps in your head as you get more and more practice at this. Over here's a similar problem. This problem here has 4x minus 6x plus 1 on the left, but 4x minus 6x is minus 2x, so it's really just minus 2x plus 1. Over here I have to distribute, so I have minus 2 times x, which is minus 2x, and then minus 2 times minus 4 is plus 8, and then of course bring the plus 3 down. Now here, the first thing I'm going to do is combine, I can combine 8 plus 3, so I'm going to make that minus 2x plus 11, and so I have minus 2x plus 1 on the left, and minus 2x plus 11 on the right. So the first thing I'm going to do is get rid of the 1 by subtracting 1 from both sides. So if I subtract 1 here and subtract 1 here, on the left it cancels, and on the right I get 10. And then finally, to get my x's all to the same side, I can add 2x to both sides. If I add 2x to this side, of course it's going to cancel. And if I add 2x to this side, wow, it cancels there too. So actually what I end up here with is 0 equals 10, and that's an impossible equation. So it is possible that you could have an equation that has no solution. So that's what's going to happen if you get an equation that has no solution. Now, let me just show you what I mean by transposing, because I'll do this in some of the problems. If I were to have an equation 3x minus 5 equals 2, rather than say, okay, I'm going to add 5 to this and I'm going to add 5 to this, another way to do it is just say, well, when you do those 2 steps, basically what's going to happen? What's going to happen is the minus 5 is going to go to the other side, and I see I actually already made an error because I was doing it in my head. But when you add 5 to both sides here, what's going to happen is you're going to get a plus 5 on the right side. So actually 3x minus 5 equals 2 is the same as 3x equals 2 plus 5. And likewise, if you have 3x equals 2x plus 4 and you wanted to get x to one side, you actually could just take this 2x and move it to the other side. But when you do that, you have to change the sign. So over here I had minus 5, and if I move it to the other side, it becomes plus 5. Over here I have 2x, and if I move it to the other side, it becomes minus 2x. Okay, now real quick, I just want to show you a couple of these little more complicated ones. Okay, this one right here is fractions. So when you have fractions, you're going to generally want to get rid of your denominator. So I'm just going to multiply everything by 6 to get rid of my denominators. 6 times a half is 3, 6 times a third is 2, so that's minus 2p. 6 times 4 thirds is 24 thirds, which is 8. And now you can read how to finish this, because this is no more difficult than any of the questions before. Notice here I just moved the 3 to the other side, and again it's supposed to be a 3. Okay, so I subtract 3 to the other side, and I get minus 2p equals 5, and then p equals negative 5 halves. On the last one, read this one on your own, but just make sure that you realize what I did here was I simplified this quadratic equation first before